Hello all, welcome. Please take a seat. Thank you for joining us today in another Canonical webinar. We're going to be exploring what is new in Ubuntu Core 24, but let's give a couple of minutes for people to join us first. Thank you again for joining us. Thank you for being here. It's good to see people joining us from our different platforms. It's good to see more and more people coming. So again, we're going to give 1 or 2 minutes for people to join us. Please feel free to start dropping your messages in the chats. Hi all. Feel free to also put where are you coming from, where are you watching us from today. The Ubuntu community is a huge community. We are glad to see people from all the different continents here. A special hi to all of our Spanish speakers here. Espero que estén teniendo un buen día. Perfect. Let's give hi all. Hola a todos. Perfect. Let's give a couple of more minutes. I think that we're in the 2 minutes mark. Good. Okay. Before we start with the introduction of Ubuntu Core 24, please bear in mind, if you have questions, just put it in the chat in the QA section for the different platforms. We will be reading your questions at the end of the presentation. Okay? Perfect. So let's begin. Ubuntu Core empowers device makers to scale by eliminating the burden of software maintenance, simplifying complex security implementations, and overcoming the challenges of managing a fleet of devices. Its fully containerized architecture brings immutability to the OS. Each element of the system, kernel, distro, applications, is a complete standalone component with a strict kernel-enforced confinement. Every element can be transactional and independently updated with over-the-air updates through deltas and rollbacks. This works in both connected and air-gapped environments. Core is the secure by design OS, so you don't need to worry about disabling physical interfaces like Ethernet or USB, removing default users and setting new permissions, hardening your kernel configuration, or being worried about your user escaping your app confinement. Out of the box, you will leverage the same tooling used today by large international manufacturing organizations deploying hundreds of secure devices to their customers. And because Ubuntu Core uses the same kernel, the same base libraries, and the same sister software as Ubuntu Desktop, you have a smooth transition from development on Ubuntu Desktop to production with Ubuntu Core. Whether you develop your application in Ubuntu using C++, Rust, Python, or more, whatever tech stack you use, you're used to using in a regular basis, Ubuntu Core lets you ship production images for your application as you develop your prototypes, as you develop your innovation. With a rich ecosystem of open source applications available in the Snap Store, it is easy for developers to build the production images with their favorite tools, from MQTT brokers, telemetry agents, DDS, system monitoring, fleet management, and more. You can leverage thousands of snaps directly on your device today. If you want to bring cloud intelligence to your device, for example, the Microsoft Azure IoT Edge Snaps allows you to easily connect your embedded system to Azure Cloud Services for a fully managed experience. If you are looking to connect your device to secure private networks, you can use snaps like NetBird. Or if you're developing an application that has a graphic user interface and you require a robust display server, you can use snaps like Ubuntu Frame that comes with all the functionalities users expect while interacting with digital displays. This includes input from touchscreen with a wide range of gestures like on-screen keyboard, remote desktop, and power-saving displays options for those deploying hundreds of graphic applications into the market. This is ideal for those building these applications, and Ubuntu Frame is here to support them. Companies like Proto are using these technologies, Frame and Ubuntu Core, as they revolutionize communication with the world's first holographic communication platform. Ubuntu Core is also the reliable OS for BeWell's CE Mark health kiosk in hospitals across EU. BeWell is empowering people with chronic conditions to live better and healthier lives. Ubuntu Core is also the reliable OS for Bosch Rexroth line of industrial PLCs and gateways, as they deliver automation solutions for the modern factory. And the sky here is the limit, quite literally. Recently, Lone Star made history by conducting a full data storage test from the moon surface. Ubuntu Core was there as they pursue their goal of safeguarding humanity's data. You can learn more about these fascinating stories and other use cases by visiting canonical.com/core. With each Ubuntu release, we help our community push the boundaries for IoT and edge devices. This new Core 24 release, our 5th LTS, is here to help you scale. We cut the factory installation time needed per devices and enable air-gap factory installations to meet demands for accelerated rollouts and secure global supply chain. Provisioning devices can be a painful and costly endeavor for device maker. As you scale, your deployment scales, and spending an hour configuring each device is no longer an option. So let's have a look at Ubuntu Core architecture. There are 5 main elements, but today I just want you to focus on 3. First, our Linux kernel, which is the same kernel as the Ubuntu LTS kernel. For example, for Core 22, it's the same as Ubuntu 22.04. For Core 24, the kernel is the same as 24.04. Second, the minimal OS based on a subset of packages from the Ubuntu LTS distribution. So again, for Core 22, we take a subset of the packages from Ubuntu 22.04. For Core 24, 24.04. And third, your applications will sit on top. All the elements in Ubuntu Core run in isolation, confined with strict kernel-enforced rules using snaps. Therefore, there is a clean separation between all of these elements, maintaining the integrity of the operation system while allowing the applications to function normally in their sandbox. If you need to update any of these elements, they can be updated independently and transactionally. To build your Ubuntu Core image with your target application and hardware, you just need to complete a model assertion, a declarative JSON file. This file is the recipe for your production image, specifying the applications, the kernel, the gadget, the base OS, and other necessary components. So once you have developed your applications in Ubuntu desktop, using whatever tech stack you like, you just have to package them. You just have to package your application using snaps, and then complete your recipe, complete this declaration, complete this JSON file, which will be used with Ubuntu Image. Ubuntu Image is the tool for generating production images, and then you will get your Ubuntu Core, your dedicated, your custom, your bespoke Ubuntu Core image for your use case. With this, you don't need to play with Ubuntu system settings anymore, worrying about pop-up dialogues, worrying about updates that you don't control, screen locks times, or simply not bringing that user experience that you want to your final device's users. No more manual software copying and pasting, and no more endless shell scripts that you have to execute after each fresh installation of your operating system. And as you can see, the base layers of these are going to be maintained by Canonical. They are going to give you that immutability as they can remain more or less the same, stable throughout the whole lifecycle of your device. Your applications sitting on top are the ones that are being consuming the new features that you, third party, or your community are developing. So, like we were saying, in this release, we remove the need to reboot after installation, greatly reducing the installation time. Besides, Ubuntu Image, the tool that we use to create Ubuntu Core images, now also uses validation sets. Before, there was no easy way for Ubuntu Image to include these validation set assertions. Now, Ubuntu Image can simply use the model to download the validation set and use it to pick the right versions, the right revisions of your applications while creating the image, reducing errors or updated needed after the first boot. Ubuntu Core also provides greater control over automatic network requests. You can now disable all network communications during device initialization. It also supports offline remodeling, allowing teams to migrate to newer core versions without internet access. And we have also reduced the size of the Core 24 snap compared to previous Core 22 release. And this work also includes removing the console COM from the system and making it available as a separate snap. Moving on, Core 24 also offers integrations with Landscape, Canonical System Management Tool, and Microsoft Azure IoT Edge. This open device management approach allows device makers to integrate their existing system management tools, their existing infrastructure, or whatever approach best fits them to the device that they are deploying. For example, let's say that you're building your Edge AI security camera using AMD KV260 vision board, that they recently released. If you pre-train model, if you have already your pre-trained model, you just have to package it as a snap to protect your IP, to protect the value of your training. And on top of that, you can have a separate snap that is, for example, your Python script that is running, the usual video capturing, OpenCV, and so on. This is a modular approach. You can have a more monolithic approach where you combine a script and a model into one single snap. It's up to you. But let's talk about the device management. You can now use the Landscape client snap to get that control of your fleet of devices, leveraging things as canary releases, remote device remodeling, or system monitoring. Let's have a look. With Landscape, you can monitor devices and receive warnings when a device has been offline for a prolonged period of time. You can also see devices processes, CPU usage, and memory information, along with other basic observability metrics. Landscape provides as well CVE notification in a nice dashboard, as you can see on the picture, showing how many devices in your fleet need an update, have not been updated, are not compliant with a security update. You can even use Landscape to connect directly to the specific device on the field and debug from the console. This is a great tool for troubleshooting. This is a great tool to that peace of mind that developers, that device makers need. For more information about Landscape, please, you can visit the documentation. But if you are using, again, systems like Azure Cloud Infrastructure, simply add the Azure Edge IoT snap for a direct connection to your Azure portal. is as simple as that, switching from one snap to another, and that applies to every single layer of the system. Moving on, new GPU interfaces have also been added in this release. Ubuntu Core 24 brings new integrations and features for GPU operation and graphics support. Developers can now use the GPU interface to embed a range of applications, from AI models running inference on the edge to products that require graphic acceleration. Going back to Ubuntu Core structure. So while snaps run in isolation, they can still access system resources without requiring privilege flags, breaking out of the sandbox, or dealing with IP configuration issues like other containers. And they do this through the use of interfaces. There are more than 130 interfaces maintained by Canonical that allow or deny a snap to access securely and easily resources outside of its confinement. For example, if your application that you're developing and you're packaging as a snap requires GPO pin access, there's a GPO interface. Sound playback or recording, there's an interface for that. Network or Bluetooth interface for that. Home directory, the same. Even if you want to access your device power settings, there's an interface for that. All of these will streamline the development process for you. For more information, you can visit snapcraft.com/documentation and look for supported interfaces. And the way that you use these interfaces is straightforward. When you're creating your snap, when you're packaging your application, you will need to complete a YAML file. This is an example of a YAML file for a robotics application, for a ROS application. And as you can see there, we are using the ROS2 Humble extension that Canonical makes available to easy the deployment and runtime of ROS applications. So in the app section, the last paragraph, you can see as well that we are including the plugs basically to what this snap needs to be connected in terms of interfaces, and it's the network and the network pin. The section apps is where we include the commands and services that we're exposing to our end users. And if today you want to check what interfaces some of the snaps that you are currently running in your Ubuntu environment has access to, if you want to check what are they consuming resources from, you just simply have to type snap connections and the name of the snap. So for example, snap connection Spotify, and you will get a list of all the different interfaces that your snap are connected to. So going back, for Core 24, this GPU interface release improves the hardware compatibility through updated graphic drivers and optimizes resources utilization via shared user space environment. Core 24 also introduces our 12-year LTS commitment. As the cybersecurity landscape is changing both in the US and in EU, new regulations will be introduced to help end users and device manufacturers alike. From full disk encryption and secure boot to strict confinement policies, at Canonical, we want to help all our innovators comply with the different cybersecurity requirements. Extending the LTS shows our commitment to support you through your journey. Other security features from Ubuntu Core are features in the snap confinement, where snaps are signed, basically helping developers understand whether or not their applications have been tampered. And in use with Ubuntu Core, you basically have that peace of mind needed when you're deploying these devices, these systems to the market. You have a better understanding whether or not someone will be able to tamper with your application, which is quite important in our industry. If you think about that, if you're putting devices that are going to be used in manufacturers with other people, it's important that the final user of the device doesn't have that access to change some system configurations that they shouldn't change, that could cause harm while using a specific device. Let's move on. If you want to learn more about Ubuntu Core 24, we have made a series of blogs coming from different engineers and directors here at Canonical that will take you through topics like deploying AI models for inference in FPGAs. It's a fascinating topic as FPGAs help you develop accelerated infrastructure for deploying AI models for the quicker AI inference. And therefore, using Ubuntu Core and FPGAs, you have that system for over-the-air updates, for security maintenance of your model, of your deployment, plus leveraging all the benefits of these programmable FPGAs. We have also made available blogs from the robotics team regarding telemetry and observability for your fleet of robots. As you scale and as your fleet scale, you also need to think about all the data that your devices are collecting. Therefore, in this blog, you will find information how to use the Grafana agent to get a dashboard on whatever server that you put in on site, in order for you to collect the data from your different devices, in order for you to store them. All the different telemetry data that, in the case of robotics, is available through the ROS topics, through the ROS messagings. A third blog that follows this series is about building a Matter Lightning device with a Raspberry Pi. Here, you will learn how to use, and more than that, how you can create your Matter application. Matter, for those of you that don't know, is a framework for smart home devices communication. And finally, if you want to learn more about device management with Landscape, our director of telemetry has made that blog available to all of us, where you can see all the different tools and features that are available with this tool, Landscape, that for years now have been supporting many enterprises that are deploying big Ubuntu deployment, Ubuntu Dexo deployment, and now it's extended its support to Ubuntu Core. And if you want to start building your first Ubuntu Core image today, the only thing that you have to do is follow our documentation. If you go to canonical.com/core/docs, you can get started in your journey, and you can find this tutorial about building your first Ubuntu Core image. Thanks to our community for joining us in this webinar. Thank you for the community to join us in this journey. We're proud to be part of your team and together building the next generation of smart edge devices. We can wait to see what you deploy next. And with that in mind, let's jump to the question section. Okay. I see a first question. Can you give me any links or example of projects using dedicated Snap stores for inspiration? That is a good question, and I think that this series of vlogs is for you. Throughout this series of vlogs, you will see different snaps that are used. For instance, I don't remember the name here, but for flashing the FPGAs while they are in operations, we have there's available a snap that will allow you to pass your bit stream directly to the FPGA without having to restart the device. The same here. You can see how you can use NetBear plus Grafana Agent Snap for you to start developing your telemetry system. And the same applies to other of these blog series. So if you want to see more examples of how you can use snaps that are already available on the Snap Store for you to deploy your devices, for you to deploy your own appliances, this blog series is a great place to start. Thank you for the question. Let's move on. Okay, so the question is how to remotely install Ubuntu snaps on Core 24. It's a good question. So if we go back to the architecture, perfect. If we go back to the architecture of Ubuntu, you will find these different elements. Let's say that you want to trigger a new update for one of your applications that is sitting on top. There's different ways that you can do this. Today, you can, if you want, you can sideload your snaps. That is a manual process where you can go with a USB, connect it to a device, and do the update. Of course, that is not the way to scale. And that's why Canonical offers you the ability to have over-the-air updates using the Snap Store for you to host and therefore get that ability to update your devices automatically. So today, many of you that are using Ubuntu are using different snaps. Millions of snaps. We have millions of snaps users. So think about that. The same reliable infrastructure that are used every single day can be brought to your device. So you can leveraging a mature product. So by hosting your snaps on the Snap Store, you can easily select in the module assertion, you can specify where the snaps and therefore what revision they should be looking, what channel they should be looking. And every single time there's a new update made on the Snap Store, the device will check a specific channel and update. There's settings that you can play with. The device can be updated automatically every 4 hours, every 6 hours, or you can specify when a device has to be updated following some logic. For example, after this specific service has been done, so we are sure that the device is not in operation. So again, if you want to leverage the over-the-air update capability of Ubuntu Core, you can use the Snap Store. And if you want a private repository for you, you can also go and acquire dedicated Snap stores. Perfect. Let's jump to another question. Why not have snaps and Flatpak for the best of both worlds? Some apps simply refuse to adopt the snap. Is too much to ask for both? This is a good question. Again, please remember that we're talking about Ubuntu Core separate from the Ubuntu desktop environment, because like we were telling you, here in Ubuntu Core, you don't download Ubuntu Core, you don't start developing on Ubuntu Core, you build your production image with Ubuntu Core. Once you have already prototype, already tested, and know that you are ready to go to market, you're ready to go to production, is the moment that you have to create your production image, okay? So it's not here where you're going to be installing different developer tools, okay? So once you have created your applications, yes, the snaps are supported as a tier 1 in Ubuntu Core, but that doesn't mean that you cannot bring Docker containers. If you follow, again, canonical.com/core/documentation, you will find information about how to run Docker containers in Ubuntu Core. If you are packaging your applications using devs, yes, you can also bring that, because at the end of the day, snaps can consume devs to make the packaging, and out of the box, you get the Delta updates, the rollback on failure, and so on. The ability for your snap to work in different Ubuntu distributions, in other different distros. At the moment, no, Ubuntu Core doesn't support Flatpak. And it is as simple as that. Go give it a try. If you try packaging your application, because again, do remember this, you will have to package your application. Packaging and snap will depend on how complex is your application, but there's a lot of resources that can help you and guide you to achieve this. And once you have packaged your application as Snap, you will leverage all of these tools that we have been discussing, the interfaces as well, to not be just another layer, another abstraction layer on the system, but also use the resources in a secure manner with the security that now you are required when you are deploying your devices, but most importantly, the security that you and your company deserve. Let's jump to a last question. Thank you for your question. I really appreciate it. Is Core for free? Yes, Ubuntu Core is for free. It's an open source tool. You can go and download it today. You can just start building your image today. There's no cost associated with that. And the following question was about architecture as well. Ubuntu Core supports AMD 64, ARM 64, ARMHF, RISC-V, and let's see what new architecture is dropped there, what innovative architecture is dropped there that deserves the attention of enabling the board. I think that's it. I know we have more questions in this channel. Sorry for that. How quick is installation of Core 24? Yes, and mentioning some issues with Core 20 in 20 minutes. This, again, like we were saying, the installation time has dropped because we have the moment that you, in the Ubuntu image process creation, you will use the validation set. Therefore, you will select exactly what revision of your snap is needed. We have also made other optimizations, like we mentioned, and it depends of your architecture. It depends of your applications. Give it a try. We have measured and we have seen that a third has been reduced. It depends. Also, I will advise you to follow some recommendations in the way that you snap your applications. There's good development practices that all of this information will help you. And again, please feel free to open questions in our Discord channels. Getting your feedback is always helpful towards building, towards improving if there's any issues that you're experiencing. Thank you for your question. Any links, books, video. Again, the Ubuntu, as part of this release, we have made many improvements to the Ubuntu core documentation. Give it a try, and please let us know if the experience is better there. Okay, and Christopher, sorry, let's take that last question. How a snap is made? As you saw, the YAML file that I put on the screen, which I cannot find at the moment, the snaps are made by declaring them on the YAML file. Here you go. You see different parts, right? So let's take this ROS robotic example, okay? This YAML file starts with a small amount of human readable metadata. It is also possible to write a script to calculate the version or to take a tag or commit from a Git repo. So we're talking about the first lines there. The base keywords define the runtime environment with a minimal set of libraries. You develop using Ubuntu 22.04, get the base core 22. This is an example. Different confinement types as well. As you can see there, we're using a strict. A strict confinement means that snaps can not access files, network processors, or any other system resources without requesting a specific access via interfaces. This is key for security reasons. If you jump down, you will see the part sections in the middle, and they define how to build your application, and can be anything. It can be programs, library, etc. Their sources can be local directories, remote Git repositories, or even tarbles. And finally, like we were mentioning, the last section is the apps, are the commands and services that you are going to expose to your end user. Each entry under apps is the command name that should be exposed to the end user. And the command specifies the path to the binary to be run. This is, again, a real example for a robotics application. If you want to learn more, I encourage you to go and have a look at the documentation. I think that we're going over time. I want to thank you all for being here. Thank you for the amount of questions that we got. Sorry for those questions that I couldn't answer. Again, please feel free to put them on Canonical Discourse. Have a great day. Thanks.